Here's another classic word problem similar to the often joked about two trains going in the opposite directions. One of your friends is heading north for a holiday, and the other friend is heading south. If their destinies are 1,029 miles apart, and one car is traveling at 45 miles per hour, and the other car is traveling at 53 miles per hour, how many hours before the two cars pass each other? And so again, here we can find the parts first. And so total distance it gives us is equal to 1,029 miles. Now we know that each car travels a certain distance. We can call those distances D1 and D2. We don't know what those distances are, but we do know how fast each car is going. So the car that goes D1 distance is traveling S1 miles per hour, 45 miles per hour. And the car that goes the D2 distance is traveling S2 miles per hour, 53 miles per hour. And we want to know the total hours. Now, the total hours the cars travel then is equal. So we can say that the distance the first car travels divided by its speed is equal to hours it travels before it passes the second car. And likewise, that number of hours is equal to the distance the second car travels divided by its speed. Now, this is called a ratio. D1 is to S1 as D2 is to S2. And we know by the rules of ratios that the sum of the numerators, D1 plus D2, divided by the sum of the denominators, S1 plus S2, will give us the same ratio as the previous two. There's a lesson on algebra ratios under this lesson on the platform. So we can solve the total hours by saying that total hours equal, of course, the distance the first car travels over its speed, which is also equal to the distance the second car travels over its speed, which by this rule of ratios, we can say is equal to the sum of the distances, which we are given, 1,029 miles, divided by the sum of the speeds, which we are given, which is 45 plus 53, which gives us 98 miles per hour. And then we'll get the answer to our question, how many hours before the two cars pass, will be 10.5 hours. And so in this case, writing the numbers in the quantities of the solution, which were hours, gave us ratios equal the solution. There's a similar problem under this one. Have fun.